Hello everybody, welcome into another lesson. So today we are going to talk about trigonometric identities. And these trigonometric identities are very critical for understanding in general how to simplify trigonometric expressions and how to solve trigonometric equations, which are going to happen quite often from here on out. So a very fundamental identity is the sine squared of theta plus cosine squared of theta equals 1. It does not matter what that theta is, so long as it's the same angle. If theta is the same angle, it could be any angle out there, the sine squared of theta plus cosine squared of theta equals 1. That is a good one to commit to memory. Now, we also have another one here, which I'm going to work through to show you. If you have 1 plus the tangent squared of theta, that's going to be equal to the secant squared of theta. Well, let's work on that. Let's show you how that works. So you have 1 plus tangent squared of theta equals secant squared of theta. Well, alright, so let's take 1 plus, now what is the tangent squared of theta? Well, what's tangent in terms of sine and cosine? It would be the same as the sine squared of theta all over the cosine squared of theta, right? Which, if we simplify this side, you want to get the same denominator, you would end up getting cosine squared of theta all over cosine squared of theta plus sine squared of theta all over cosine squared of theta. Well, what do you know? You have the same denominator. So you can add the two numerators. Well, what's cosine squared plus sine squared? It's just 1, right? So this would be the same as 1 over the cosine squared of theta. Well, what is 1 over cosine squared? That's just secant squared, right? So therefore, we can say, so let's say, therefore, 1 plus the tangent squared of theta equals the secant squared of theta. So that's how I was able to prove that 1 plus tangent squared of theta equals secant squared of theta. And then we have another one like this. If you take 1 plus the cotangent squared of theta, that's going to be equal to the cosecant squared of theta. So 1 plus cotangent squared of theta equals cosecant squared of theta. Again, let's prove that. So you have 1 plus, now what is cotangent? That is cosine over sine. So that'd be 1 plus the cosine squared of theta all over the sine squared of theta. Now let's simplify this left-hand side, which means you want to get the same denominator. So this would turn into the sine squared of theta over the sine squared of theta plus the cosine squared of theta all over the sine squared of theta. Well, we have the same denominator, so add your numerator. What's sine squared plus cosine squared? It's 1, so you would just get 1 over the sine squared of theta, which we know 1 over sine is cosecant, so that would be the cosecant squared of theta. So therefore, we can say that 1 plus the cotangent squared of theta equals the cosecant squared of theta. So very important identity there for you. Alright, so what we just did were called Pythagorean identities. And you could set up right triangles and illustrate it that way too, but we didn't need to do that. Now we have what are called cofunction identities. So, cofunction identities. So, if you have the sine of pi over 2 minus x, that's going to be the exact same as the cosine of x. So, let's do an example. Let's say I literally put in pi over 2 for x. So, sine of pi over 2 minus pi over 2 is what? 0. What's the sine of 0? Well, that's 0. Now, I had pi over 2 for x, right? So that means the cosine of pi over 2 is 0. So that's just one example, but if you take x away from pi over 2, so sine of pi over 2 minus x equals the cosine of x. And likewise, let's say I do the cosine of pi over 2 minus x, I would end up getting the sine of x. So if I put in that same pi over 2 for x, well, that would give me the cosine of 0, which we know is 1, and then the sine of pi over 2 is 1. So the sine of pi over 2 minus x is cosine of x. Cosine of pi over 2 minus x is sine of x. And then likewise, if I want to do the secant of pi over 2 minus x, I would also get the cosecant of x. And if I did the cosecant of pi over 2 minus x, I would end up getting the secant of x. And then, of course, same with your tangents. So if I took the tangent of pi over 2 minus x, I would end up getting the cotangent of x. And then if I did the cotangent of pi over 2 minus x, I would end up getting the tangent of x. So these are all your cofunction identities, and you could put in any angle and you would see that it's true. So these are all your cofunction identities. So sine of the quantity of pi over 2 minus x is the same as cosine of x. Cosine of pi over 2 minus x is the sine of x. Secant of pi over 2 minus x is the cosecant. Cosecant of pi over 2 minus x becomes the secant of x. Tangent of pi over 2 minus x becomes the cotangent of x. And then the cotangent of pi over 2 minus x equals the tangent of x. And then we have the last identities to give you for today before we go into working some of these out and simplifying are negative angle identities. So we have negative angle identities. So we have 2 of the 6 functions are even. So if you have the cosine of negative theta, it just becomes the cosine of theta. Of course, what's an even function? In general, if you take f of negative x, you should get back f of x. That's an even function. Well, cosine does that. So cosine of negative theta equals the cosine of theta. Well, let's say I took the negative of a first quadrant angle, negative pi over 4. If I took the cosine of negative pi over 4, that's in the 4th quadrant, right? That would be the same as the cosine of pi over 4 in the 1st quadrant because the cosine is positive in both the 1st and 4th quadrants. Or if I did the cosine of negative 3 pi over 4, that's in the 3rd quadrant. That would be the same as the positive cosine of positive 3 pi over 4 in the 2nd quadrant because the cosine's negative in both the 2nd and 3rd quadrants. So cosine's an even function. Cosine of negative theta equals the cosine of positive theta. And since the secant's the reciprocal of the cosine, you can say the exact same for the secant of negative theta. The secant of negative theta equals the secant of positive theta. These are the only two that are even. Now all the rest are odd. So if you take the sine of negative theta, you'll end up getting negative of the sine of theta. So it's kind of nice with these odd ones. You can just take that negative sign from inside the parentheses and move it outside with these odd ones. So sine of negative theta equals negative of the sine of positive theta. So let's take that same negative pi over 4, right? That's in the fourth quadrant. Well, that'd be the same as the negative of the sine of positive pi over 4, because the sine's negative in the fourth quadrant, but it's positive in the first. So this would prove that that works. And then, of course, the cosecant is just the reciprocal of the sine function. So we know for a fact then that the cosecant of negative theta would be equal to the same as the negative of the cosecant of theta. And then tangent and cotangent are just ratios of sine to cosine. So this means that the tangent of negative theta is going to equal negative of the tangent of theta. And then the cotangent of negative theta is going to equal negative of the cotangent of theta. So cosine and secant are even, and then all of the other four functions are odd functions. So these are really going to help us. Now we're going to simplify some expressions here. We're going to put what we just talked about to work. So our objectives for these next exercises are to simplify. Alright, so there we go. Let's say you're asked to simplify the cotangent of x times the secant of x. You've been asked to, well, it'd help if I have cotangent of x, not just cotangent. Alright, cotangent of x, secant of x. Well, to best simplify this, it's important to understand probably what these are in terms of sine and cosine. So cotangent of x is what? That's the cosine of x over the sine of x times, now what's your secant of x? Well, that's 1 over cosine of x. Now notice your cosines are going to cancel out, so you'll be left with 1 over sine of x, which we know 1 over sine of x is the cosecant of x. So the cotangent of x times secant of x would simplify into the cosecant of x. Alright. Now the cosine of negative x over the sine of negative x. So the cosine of negative x over the sine of negative x. Well, the cosine of negative x, since it's an even function, would just become the cosine of positive x. But sine's an odd function, so that sine of negative x would become negative of the sine of x. So this would just turn into negative of the cotangent of x. So this will simplify into negative of the cotangent of x. Alright, let's see. Secant of x, cosine of negative x, whoops, not equals, but minus sine squared of x. So we got to simplify secant of x, cosine of negative x, all that minus sine squared of x. Okay, so let's deal with that negative identity. So what's the cosine of negative x? Well, that becomes the cosine of positive x. So you'd have secant of x, cosine of positive x, minus the sine squared of x. Well, alright, what is secant? Well, that's just going to be 1 over the cosine of x, all that times the cosine of x, minus the sine squared of x. Well, your cosines cancel out. This would just turn into 1 minus the sine squared of x. Well, hang on a minute. What's 1? 1 is literally the cosine squared of x plus the sine squared of x. That's 1, right? All that minus the sine squared of x. And what are you left with? Just the cosine squared of x. So this would all just simplify into the cosine squared of x. Alright, the sine of x times the quantity of 1 plus the cotangent squared of x. So we have the sine of x times the quantity of 1 plus the cotangent squared of x. And some of you are probably thinking, well, why don't we distribute this? There's an even better way. What is that identity for 1 plus cotangent squared of x? It's just simply cosecant squared of x, right? So this will turn into sine of x times the cosecant squared of x. Now, what is cosecant? Well, that's just 1 over sine, right? So this will be sine of x all over 1. Sine of x times 1 over sine squared of x, which this would just turn into 1 over sine of x, or simply the cosecant of x. So this will all turn into the cosecant of x. This is why knowing your identities is so important. Alright, 1 minus sine squared of the quantity of pi over 2 minus x. So we have a cofunction identity here. How are we going to simplify this? 1 minus sine squared of the quantity of pi over 2 minus x. Well, what is sine of pi over 2 minus x? That's cosine, right? So this would turn into 1 minus the cosine squared of just simply x. Well, what's 1? 1 is going to be that cosine squared of x plus the sine squared of x. All that's for 1, then minus the cosine squared of x, which would just turn this into the sine squared of x. This would all just simplify into the sine squared of x. Alright, let's see here. We have the tangent of pi over 2 minus x all over cosecant of x. So how are we going to simplify that? Tangent of pi over 2 minus x over the cosecant of x. Well, this is a cofunction identity. So what's tangent of pi over 2 minus x? That would just turn into the cotangent of x, right? So now you have the cotangent of x over the cosecant of x. Well, what's cotangent? That's going to be cosine of x over the sine of x. All over what's the cosecant? That's 1 over the sine of x. Alright, so now with these fractions, we'll invert and multiply. You'll get cosine of x over sine of x times the sine of x over 1. While your sine of x cancels out, you're literally just left with the cosine of x. So all this will simplify into just the cosine of x. All right. Let's see here. We have the cosine of pi over 2 minus x, all that times the cosecant of x. So cosine of pi over 2 minus x times the cosecant of x. Well, what's that cosine of pi over 2 minus x? That's literally the same as sine of x, right? Now, what's the cosecant of x? Well, that's just going to be 1 over the sine of x, which the sines cancel out. This just turns into 1. So all you get for your answer is 1. All right, let's see. Sine of negative x over the cosecant of x plus the cosine squared of negative x. How are we going to simplify that? Well, let's look at this here. So sine of negative x, that's the same as the negative of the sine of x. What is your, well, this will be over 1, negative sine of x over 1. Now, what's the cosecant of x? Well, that's 1 over the sine of x. Now, what is the cosine square of negative x? Well, cosine of negative x turns into the cosine of positive x, so this would all be plus the cosine squared of x. Now, invert and multiply this fraction, you'll get negative of the sine of x all over 1 times the sine of x all over 1 plus the cosine squared of x, which would turn into negative of the sine squared of x plus the cosine squared of x, which this is a way you can leave it. You can leave it as negative sine squared of x plus cosine squared of x. You could also use other identities for, like, the sine squared of x is the same as 1 minus cosine squared of x. Or you could do that the cosine squared of x is 1 minus sine squared of x, and you could get something based on just the sines or cosines. But actually, as this turns out later, when we get to double angle formulas, this will be the cosine of 2x, but we're not going to do the double angle formulas today. But that's about the best we can do with that one. Good one. So we have the cosine squared of x tangent squared of negative x minus 1 all over the cosine squared of x. Alright, so let's see. We have cosine squared of x, tangent squared of negative x, all that minus 1 over the cosine squared of x. Well, it might help to separate this into two terms. Since we have two terms in the numerator, this will end up being the cosine squared of x tangent squared of negative x all over the cosine squared of x minus 1 over the cosine squared of x. Alright, so notice with your first term, your cosine squareds will cancel out, and now you're simply left with the tangent squared of what's tangent of negative x? Well, that'd be negative tangent of x, but if you square the negative tangent of x, you get positive tangent squared of x minus, now what's 1 over cosine squared? That'd be tangent squared of x minus secant squared of x. Well, what is the secant squared of x? That's the same as 1 plus tangent squared of x, right? So this would be the same as tangent squared of x minus the quantity of 1 plus the tangent squared of x. Well, what do you notice? Your tangent squareds are gone. You're just left with negative 1. So all you're going to get is an answer of negative 1. Alright. Secant squared of x minus tangent squared of x. Well, how are we going to simplify this? There isn't a whole heck of a lot we can do, but probably the best thing you could do is take that secant squared of x, get it in terms of the tangent. So we know the secant squared of x is still going to be that 1 plus the tangent squared of x. Well, never mind, I answered my own thing. 1 plus tangent squared of x minus the tangent squared of x, we can do a lot with it. Well, your tangents are gone, you're just left with 1. So there, you got an answer of 1, and actually this is a very important one to kind of work backwards with. You just get an answer of 1. Alright, what's next? Good one. Tangent of the quantity of pi over 2 minus x times the secant of x all over 1 minus the cosecant squared of x. Okay, so let's start with each the numerator and denominator. So what is the tangent of pi over 2 minus x? That's the same as the cotangent of x, right? So we have the cotangent of x times the secant of x. Now let's work on simplifying that denominator. Okay, so what's cosecant squared of x? Isn't that the same as the quantity of 1 plus the cotangent squared of x? Alright, so now you have 1 minus the quantity of 1 plus cotangent squared of x in the denominator. So this is going to simplify further into the cotangent of x times the secant of x. Now your 1's cancel out in the denominator, so this would just be over negative cotangent squared of x, which will simplify even further into just simply negative of the secant of x over the cotangent of x. So now we just deal with the fractions, so that negative secant of x is the same as negative 1 over the cosine of x in the numerator. All over your denominator, that cotangent of x is the cosine of x over the sine of x, which will invert and multiply all this. You'll get negative 1 over the cosine of x times the sine of x over the cosine of x, which would just, the best we could do with this, to be honest with you, is going to end up being negative secant of x tangent of x. So the best you could get for this is negative secant of x tangent of x. All right. Cosine of, we got pi over 2 minus x. All that minus 1 all over 1 plus the sine of negative x. Well, okay, so what is that cosine of pi over 2 minus x? That's the same as the sine of x, right? So this would just turn into the sine of x minus 1 all over, what's 1 plus the sine of negative x? Well, sine of negative x is negative of the sine of x, so this would be all over 1 minus the sine of x. Well, in the denominator, we can factor out a negative 1, right? So this would be the same as the sine of x minus 1 all over negative of the sine of x minus 1. Well, what do you know? The sine of x minus 1's cancel out. You're just left with negative 1. So this would simplify into negative 1. All right. I got 4 more. All right, cotangent of x, cosine of x, all over tangent of negative x times the sine of pi over 2 minus x. And I actually think for once we're going to start with our denominator. So what is, all right, so let's keep the numerator the same for now. Let's just leave that alone. Cotangent of x times the cosine of x. Now, what is the tangent of negative x? That's just negative of the tangent of x. Now, what's the sine of pi over 2 minus x? That's also the cosine of x. Well, there you go. You have the cosines of x will cancel out. Okay, now what is the cotangent of x? That's literally the same as 1 over the tangent of x all over negative of the tangent of x. So invert and multiply. This will be 1 over the tangent of x times negative 1 over the tangent of x. This would just turn into negative of the cotangent squared of x. So this will simplify into negative of the cotangent squared of x. Three more. Secant of x, sine of x, plus the cosine of the quantity of pi over 2 minus x. All that all over, did I get that right? Yeah. 1 plus the secant of x. So we have a bit of a doozy here. So we have the secant of x sine of x plus the cosine of pi over 2 minus x, all that all over 1 plus the secant of x. Well, alright, so what is the cosine of pi over 2 minus x? That actually becomes the sine of x, right? So the numerator would turn into the secant of x sine of x plus the sine of x all over 1 plus the secant of x. Well, what do we notice about the numerator? You can factor out a common sine of x, right? So this would turn into the sine of x times the secant of x plus 1 all over that 1 plus the secant of x. Well, what do you know? Your numerator and denominator cancel out. You're just left with the sine of x. So all this is going to simplify into the sine of x. I got two more. Let's see, we have the cotangent squared of x plus the sine squared of x plus the cosine squared of negative x. So we want to simplify all that. Well, leave your cotangent alone for a minute, but even leave the sine alone for a minute. What's that cosine squared of negative x? Well, we know the cosine of itself of negative x is the cosine of positive x. So this would actually turn into the cotangent squared of x plus the sine squared of x plus now the cosine squared of positive x. Well, look at this piece right here, the sine squared of x plus cosine squared of x. What is that the same as? That's literally the same as 1, right? So this would turn into the cotangent squared of x plus 1. Well, 1 plus cotangent squared of x is the cosecant squared of x. So all this is going to simplify into the cosecant squared of x. And I got one more, then we're done. We have the tangent of the quantity of pi over 2 minus x times the cotangent of x minus the cosecant squared of x. Alright, so let's consider this. What is the tangent of pi over 2 minus x? That's the cotangent of x, right? So you'd have the cotangent of x times the cotangent of x minus the cosecant squared of x. Well, cotangent of x times the cotangent of x is the cotangent squared of x minus the cosecant squared of x. Now, we have an identity for the cosecant squared of x, right? What is that? That's 1 plus cotangent squared of x. So if you take the cotangent squared of x minus the quantity of 1 plus the cotangent squared of x, you'll end up, the cotangents will cancel out, you'll just be left with negative 1. So all this would simplify into negative 1. So that's it for trigonometric identities, for learning them and simplifying them. Next lesson we're going to verify trigonometric identities. So I hope everyone has a great day. Take care.